Hey, welcome back, all you crazy cats. System of measurement used in the United States, similar to British imperial system of measurement, but not identical. All right, they're not exactly the same. Things I want to point out to you here. Now, length is going to be measured in inches, feet, or miles. Mass is in slugs. Get that. Mass is in slugs. All right, the number of slugs. Force, all right, which is also weight, is the pound. Time is in seconds still, and then temperatures in Fahrenheit. All right, recording measurements. Measurements must always have units. All right, trying to get that into your head. All right, that's going to be one thing. On labs and assignments, every time you have a unit missing, I'm going to have to take off a point. It's about the only way I know to get you guys um, to do it. Measurement is only good if you know that it's reasonably close to the actual quantity. It is important to indicate the accuracy and precision. The accuracy and precision. We'll be talking about that again today. Hey, guess what? There's our precision and accuracy. Precision, all right? Hopefully some of you guys are starting to read. Precision is repeatability. All right, I about really butchered that one up. Precision is repeatability. Accuracy is the degree of closeness. All right, accuracy is the degree of closeness. Um, Down here at the bottom, again, this one, all right, is very accurate because it's all very close. This right here is very precise because it's repeatable. It's going to keep hitting the same spot. But this is high accuracy and high repeatability. There's a difference. Again, accuracy is closeness. Precision is repeatability. Don't forget that. Ideally, a measurement device is both accurate and precise. Accuracy depends on calibration to a standard. Okay, general rules. I know some of this is review, but we're going to hit it again. Hopefully, if we talk about it a few days, you'll remember it. Digital instruments. Read and record all the numbers, including zeros, after the decimal point, exactly as displayed. Decimal scaled instrument. Record all the digits that you can certainly determine from the scale markings. And then the last part, estimate one more digit. We did that yesterday with our rulers. All right. Fractional length measurement. A typical ruler provides. All right. Here's a typical ruler. This is measured in inches. You see the 1, 2, all the way out to 12 inches here. Each inch is graduated into smaller divisions, typically 1/16 inch increments. And on here, that one there, if we were to keep putting little marks, there'd be 16 of those between here and there. All right, there'd be 16. Got it? All right. Okay, on your rulers, the ones that are identified are the inches. And sometimes you'll see rulers that identify more than just the inch, but the big one here, the numbers are the inch. And you'll see that here, 1 inch, 2 inch, and so forth. But that's the inch. The next biggest one gives us the half inch. You'll see that then on here. You've got the next biggest markings, for example, here and here. Those are marking off in half inches. So this is a half inch, 1.5 inches. This would be 2.5 inches. The next smallest ones are 1/4 and 3/4. Then we go 1/8, 3/8, 5/8, and 7/8. And then finally, they can break that down into sixteenths as well. Measurement using a fractional scale. How do we determine 5/32 is midway between 1/8 and 3/16? Well, what they do is they convert each fraction to a common denominator of 32. And to do that, a lot of steps they do here. All right, but typically, notice they go up here to the next biggest unit. They go 8th, 16th, and the next biggest one, if you keep multiplying by 2, this here they times by 2. And if you multiply by 2 again, you get the next biggest unit. So what you do is convert them both into the next biggest unit, and then you find the one in the middle. Well, what's the middle of 4 and 6? 5. 30 seconds. Hopefully that simplifies things for you guys a little bit. Let's do another example here. Let's say we had 1/4 and 1/2. Well, again, the 4 is the bigger number, so I'm going to multiply. I'm going to change everything into eighths. 4 times 2 gives me 8, and then I can take 2 times 4 and give me 8. Well, what's 1 times? This was times 4, so this has to be times 4. This gives me 4/8. I took this times 2, so I got to multiply this by 2, and that gives me 2/8. Well, what's in the middle of 2 and 4? 3/8 is in the middle of 1/4 and 1/2. This is what I want to point out here. We need to record fractional measurements to the nearest 1/32nd, all right? Which means that that measurement that we just did is not done yet. So now that we've realized how far we have to go, all right, with decimals, we said we had to go one more decimal place. We had to estimate. With fractions, they tell us we have to go to the nearest 32nd. So let's go back to the problem we just did. 3/8 is good answer, but it's not to the nearest 32nd. So I take that times 4 and that times 4, and we get 12/32. Now, I know lots of you guys are saying, but, we have to reduce. All right, we want to take it out to the nearest 32nd and then reduce if we can. All right, and what does 12/32 reduces down to? It reduces down to 3/8. So some of you guys are saying, well, why am I going up to 12/32 if I'm just going to reduce it back to 3/8? Well, you don't have to. Some of you guys are going to recognize that right away. Well, if I multiply by 4, that means I would just be able to turn right around and divide by 4. But typically we want to go out to 30 seconds. And you notice here, in the problem they showed up here above us, what have they gone to? They went to the nearest 30 seconds. And then reduce if possible. So let's do one more example. And I might do this one a little bit different here. All right. I'm going to do it right here. Let's say I had 1/8, and another measurement was 1/4. Well, I'm thinking what might be an easier way for you guys to do this is automatically convert them into 30 seconds. 4 times 8 is 32. 1 times 8 is 8/32. That's an 8. You can't see real well there. Take this times 4 and this times 4, and I get 4/32 and 8/32. Well, what's right in the middle of the 4 and 8? 6/32. Now reduce it, and I get 3/16, and you're done. So I think what we're going to do here, we're going to do this. We're going to say automatically go to the nearest 32nd, find what's in the middle, and then reduce it. Hey, hope that was beneficial for you guys. I want you guys to take some time here to make these measurements. So go ahead and pause it. When you turn it back on, when you unpause it, I'll have the measurements there for you. Okay, what I went through here then is some of them were exact measurements. This is 1/2, this is 1/4. Here, we had a measurement that wasn't quite to 1, so I said that's 7/8, that's 8/8, 28/32, 32/32. Notice I'm going to the 30 seconds, and in the middle of them is 30, which reduces down to 15/16 of an inch. This is exactly 1 3/4 inches. Here we had 2 3/8, 2 7/16, because here is 1 2 3/8. This right here is 1 2 3 4 5 6 7/16. So that gives me 14/32 and 12/32. The middle of that then is 13/16. And that should actually be 13/32. I had to fix that. I'm glad I went over that. 2 13/32 of an inch. The last one, it's a little bit more than 3, but not quite to the 16th. That's 3 1/16, and that's 3 inches. So I said 3 0/16, 3 1/16. Converted them to 30 seconds. We get 0/30, 2 30. Right in the middle of that is 3 1/32. Well, hey, I want you guys take some time and try to answer these questions. And I'll catch you guys on the flip side.